Okay. So we have two things new to do today, and it depends on how long we need to spend on doing the whole thing. This is pre-calc. The sketch the curve and eliminate the parameter. I don't know. If we were to sketch the curve, parametrics, we have time, x, and y. How do I graph with three different variables?
Looking for time, see what they both give you.
So does time get graphed, or does time give us, how do I?
I'll just put a number in for time. I don't know, maybe 0.
Okay, so time is not on the graph. So Owen is saying, pick some t values, some time values, and then it's saying 0 to 2 pi. I'll do what you said. So we're going to plug time into x. What is cosine of 0? 1. Yeah, okay. What is sine of 0? Okay. So I'm going to plot the coordinate. How do I plot the coordinate? Time 0, x1, y0.
1. Just 1.
It just that dot there. Time is no longer involved. I use the time to then plug it in and get the coordinate. All right. Amelia, pi over 2. What is cosine of pi over 2?
0.
And what is sine of pi over 2? 1. And again, I'm not plotting pi over 2. That was time. I'm going to plot the coordinate 0, 1. All right. Nick, cosine of pi.
That's -1.
And then sine of pi.
0.
Okay, so time is not graphed, but it's, yeah. So it looks like that. The point of time is showing us the path that it's taking. Like over time, this is where it's going and how it's going. And for the most part, they will either give you the graph already, or they'll let you use a calculator to graph it, which I'll show you guys in a second. But the pre-calc part, I want you to remember how to do this, and I don't think you do. Anyone got any clue on how to eliminate the parameter? How to get t out of the equation?
Did you do something with like the equation for like a rectangle or something? It's like x squared.
Close. Here's the hint. Sine squared of anything plus cosine squared of that same anything. I would say one. Yeah. Okay. So here's the trick. I'm going to square this equation. I'm allowed to do that, right? If I say x equals 2, doesn't x squared equal 4? Like, that's still true. And I'm going to square this one. This is pre-calc. If y equals sine, doesn't y squared equal sine squared?
Use a circle.
And then if I add them straight down, x squared plus y squared equals cosine squared plus sine squared, which is 1. As he said, it's a circle centered at
0.
the origin with a radius of 1. Okay? All right, so Chris, with that as the hint, how would you do B?
This is the same way, but like move the coefficient around.
Move the coefficient around. X over 3 equals cosine, and y over 2 equals sine. What was the next trick that we had to do? Square them? Then what, Becca? And I should write the whole cosine squared and sine squared out, but I don't want to. Is this also a circle? I'm seeing some
Oh, no,
very
it's
strong
your-
affirmative yeses and then some not now. You're to the circle or you're to the not circle?
You're to the circle.
You're to the circle. Annie is not
Yeah.
saying the word, she's spelling it.
He said, I don't want to take my time. She said.
Ellipse, it's an egg,
Why you are
and
two.
not that they're gonna ask you, sorry, guys. It's an ellipse, yeah. Is the egg, okay, here's the bonus question, is the egg laying down or is the egg standing up?
It's spelling.
You're
Laying down, why do you know? The bigger number, yeah. Major axis, minor axis, those of you who are headed into physics, you are really gonna have to brush up on comic sections. Those of you not going into physics or mechanics, yeah, you might need it. Anyway, all right. So parameters eliminated. We got time out of the equation. Can you guys take out your calculators? I just want to show you how to do these should you need to.
Can you do it?
This is perhaps some foreshadowing that one day we will need to.
If you are bit in the butt by a parametric equation somewhere in your life in the future, would you be able to like wrangle it into
You can whip out your
sufficient
TI for calculator.
which, you know, they don't let you use it in college. Because it does too much for you, you make you use a TI 30.
30? Yeah, my brother complained. That's like 54 less than what we write now.
Okay, do you guys know how to put your calculator in parametric mode? Yeah, you hit the mode button and you go, not in degrees, you hit enter. Ooh. Okay, so guys, this is something you probably haven't noticed. There's function mode, parametric mode, and the next one is polar and then sequential. Right now, I'm on the second one. If I hit y equals, keep hitting the board. Now I hit y equals and the stuff looks weird. So, okay. The equation for the first thing, David, was 3 cosine.
It was, 3 cosine.
Okay, so 3 cosine, and the key next to the alpha, it says x, comma, t, comma, theta, comma, n. We are in the second mode. When I hit this, it's gonna give me the second variable. Don't put the t in for you. Okay? And then the other one was 2 sine t,
How does it just press the X button?
Yeah.
Oh, okay.
because you're in the second mode, so it chooses the second letter that's on here. All right, here's the trick I want to make sure you see.
Oh, snap. I just grabbed it. It's looking nice, man.
Okay, but all right. I arrowed all the way to the right. So I'm sorry, left. I'm on the other side of the X. If I hit enter once, it says, I'll draw a thick line for you. I don't want that. If I hit enter again, I lovingly call this one bunny hop with turd trail. For the reason I will show you in a minute. They told me on the other thing to draw from 0 times 0 to 4 pi. So I'm going to put in 0 to 4 pi. And then I think they told me other window values.
How did you make it the bunny hop with the turd thing?
Bunny hop with turd trail. In the y equals, go all the way,
It's change the line style.
line style by
It
hitting
was
the
the
enter.
X max.
Okay, but can you watch up here? So bunny hop, turd trail. There goes bunny, 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 run, bunny, and bunny is going to run on top of his trail again. You can't see that unless it's in animate mode. Those of you with a TI 84 silver or whatever, it's in color and all that.
What was the thing you did? I can make the line.
And then make it draw like that. Annie, you got it?
It's freaking awesome. There's so many line colors. My lines are magenta now.
You.
In this basket.
Mine is.
Are you ready, bro?
Yeah, but it's really funny.
Whoa.
That's tough.
Oh, you're in the
So funny, pal.
Mine's something like this.
What's your window?
Get it to like big circular.
Oh, wait, I think your window's off. Your window is zero.
I'm gonna put like.
That's what yours looks like.
How did you do that? I want that. I don't want whatever the hell this is.
First time, what did you click that made it do this?
Zoom 6. It just so it just brings it back to the 10 negative. Oh, it works.
Okay.
Look at that.
Oh my god, incredible. Try it.
It's so automatic. Cheers. I got it to work.
Yeah.
Like I've remembered.
I think Santa's everywhere.
Oh, mine was doing that too. I have to wait a set order.
It comes loaded with these images.
I did Zoom 6.
Let's go.
It's all it comes preloaded with all these little images.
I did it.
Okay, guys,
I remember the day before.
you guys are saying, am I gonna have to do this? All right. Just the heads up, again, they will probably give you the graph. If they ask you which way does it move and you don't know how to use your calculator, plugging in 0, cosine of 0 is 1, so the x value is 1, sine, well, sorry, we'll do this one. X was 3 cosine t, y was 2 sine t. When t was 0, the coordinate was 3, 0. So you got that dot. So if it asks, where does it start? Which way does it go? And again, if you're like having issues wrangling the calculator, put in pi over 2. That coordinate is 0, 2. Okay, so it looks like it went that way. They gave me the graph. I know what's going on. I started here and it went that way. All else fails, you do hopefully know some unit circle of those guys, and you can tell which way it started and go. Cool. And eliminating the parameter with trig is usually the tricky one. Usually, if it's x equals 3t and y equals 5t squared, you can solve for t is x over 3, plug in the x over 3 and square it, and you get rid of the letter t. Algebra, you guys are pretty good with. Yes? Okay, so that's old parametrics. Here's a little bit of oops. Here's a little bit of new. We did derivatives of parametrics in September.
Not US. It wasn't like.
Okay. Just making sure we can still find dy dx in a parametric form. Jacob, if x is 5t and y is 10t squared plus 5, how would I just find dy dx from our chapter 3 material?
You would take the derivative of both with respect to c.
So what is dx dt?
But
Perfect. What is dy dt?
20.
Okay, well, that's not very exciting. Austin, then what is dy dx? 20t over 5, which is 4t. Okay, simple enough? So we remember that. Okay. The hard thing is double derivative. Double derivative being that. And never made a big deal about the notation. It's the change in y twice over the change in x squared. Usually, y is position. First derivative is feet per second, change in position over time. But second derivative is how is your velocity changing? It's not change in y, it's the change in velocity. That's how did y doubly change in 1 second as, to get acceleration. It's feet per second squared. Okay. If I do the derivative of that with respect to time, does that give me dy 2 over dx squared? I'm really saying nah. Which she's right. But in the example we have, what is the derivative of this stuff with respect to time? 4? Yes. Correct. So it was simple, right? But this is not what we wanted.
Why?
Well, because I want dy, I want acceleration. I don't want whatever that is. The way to fix this,
What?
we need to do one more step. Let's just look at the variables. That one more step, I'm doing the change in y twice over dx, and then there's a dt. That dt is there too. Dividing by this is multiplying by the reciprocal. Just saying, the catch is we now need to divide by that dx dt again. Dx dt was 5, so there's double derivative. All right, let me uncover the formula for you and go from there. I don't like the way they write it, so I'll write it again. The one in green is officially what you're doing. David, any questions? Scores?
So on the top of the fraction there's just a d. So is that like you just find the derivative?
This is the change in word problem-y things. The change in velocity with respect to time over the dx. Okay. Let me have you guys try Can I change the page yet?
No.
So we find dy dx, then we do the derivative of that, and then we divide by dx dt.
Yeah, because when you do the derivative of dy dx, it's with respect to time, and we need it to be with respect to x. Change the page? What? Hold on. It's multiple choice. Try that one.
Oh, yeah.
Okay. So that,
And he's happy. Multiple choice. Yay! Let's make that shorter.
Rick. This bastard, they just tried to kiss me.
And by Sunday, please finish the Unit 7, Level 2. Those of you going on the music trip, finish it before you leave. Are you going on the music trip? Who is going?
I will. I wish I could go.
Because they hate you.
Well, I knew that already.
They're just jealous, that's all.
Okay. Get it out there. Over to the dy over dx. Just derivative of dx. So the derivative of b divided by 2a.
What is going on here?
B. And how I do this.
Oh, wait, no, this is a constant. Remind me.
Multiply derivative
David, why are you doing the screen look? Step one? Okay, I'm asking you to do the double derivative. Can you at least do the first derivative?
Yeah.
How do we do the first derivative?
Is it? You just apply the derivative.
All right, bring it on. How do I do that?
Fair. A times 2t.
What is a times 2t?
2ax. You find the derivative of x.
What is it called? Give me the name.
Straight blank.
The derivative of that, the change in x with respect to time, dx dt, multiplied by the power. A is a constant, so it's just there. Lower the power. Shh. What's the dy dt? B. All right, Cleo, what is dy dx?
2 over 2et.
Perfect. All right, first derivative done. Unfortunately, we need to do the second derivative. Chan, what would I do next?
You would differentiate dy dx in respect to dt.
Okay, there's a hard way and there's an easy way.
You can just, well, it's negative b over 2a t squared.
That's the easy way, thank you. The b, the 2, the a, just constants as given in the problem. Those guys are all just numbers. So all he did was power rule. Multiply by the power, lower the power, leave the alphabet soup, which are all just constants.
It was easy.
Okay, but we're not done because we didn't find double derivative. Wait, it's still got a t. So what's the last step? Divide by dx dt.
Yeah, which is 2at.
Divide by dx dt, which dividing by that is multiplying by the reciprocal, which looks like negative b over 4a squared t cubed d. Spell got it. Poker face, don't play poker, you'll not.
I already tried.
Doesn't go to it. You got it? You're right, like easy mark, you should play. Ah! I have a royal flush. First of all, I wouldn't believe you, statistically, so not possible.
You're wrong.
Yeah,
So when you do the derivative of dy over dx, why don't you change
here, a and b, they said in the problem are constants, so this is really just 1 over t. And I'm doing the derivative of the first time with respect to t.
So why don't you let me be sweating?
Why don't you constants go away?
I'm the trophy. Okay.
What's that one gonna be? 3 over 5t, what's the derivative of that with respect to t?
11, 2 more minutes.
Multiply by the power, lower the power. They say. All right. So that was there's double derivative. The point of the homework tonight, please do it, I will check, is that you practice it. There is one more concept we need to do today. And that's finding the length of a curve. Again. This time the curve is a parametric. When I did this one, y equals x squared, if we wanted the length of the curve, I was like, okay, well that was change in x, change in y, and we went from one x to the other x, and did the square root of 1 plus the slope squared. Is it at all familiar?
Yes.
It said like no. Okay. Well, that was when it was a regular old function. The beauty of parametrics, we can find the path of something over time that doesn't have to be a function. Maybe we let the balloon go and it went woo, and it crossed over itself all over the place, and you can track, if you have an equation for that, how long did that balloon go? And it's super easy. If you zoom in, I can be like, oh, and they're really itty bitty teeny tiny. This is dx, that is dy, but if my things are parametrically defined, they're dt's, right? So the arc length, the change in x squared plus the change in y squared under the square root. And I'm going to be integrating with respect to how time is changing. Jacob, these dt's, are they in the denominator or the numerator?
Denominator,
Are they squared?
yes,
But are they squared and under the square root?
yes.
So I factor them out, would they cancel with this dt? Like
Yes.
in the end, and I get just dx squared plus dy squared and the square root, which is Pythagorean theorem. Yeah, so there's your formula. It's printed prettier, so larger than life. There's how to find the length of a parametric.
Oh, that seems useful.
Almost always a calculator question, so you need to be able to type.
Sorry, you said the DTs cancel out, so it's just the square root of.
Well, I mean, yes. I mean, that's it, dt squared underneath. And that dt, change of time, it's all your little slivers of rectangles that we're finding the areas of and adding together.
So if we write the formula, it's
It needs a dt. Yeah. Okay. Ready? There's a problem of putting all of it together, which may or may not go over so well. There's all the pieces.
Okay, then.
Who's that? So that part of the day is pretty hard.
Yeah.
Oh. Is this the new money she keeps doing, bro?
Daddy.
It's so scary.
I'm just gonna make my little tape. T, X, and Y.
You said T, X, and Y.
Except I don't know what the number is, because I trade and a normal number.
All the numbers choose.
It's hard.
Like the numbers in between, either 2 squared minus 4 or minus 5, I don't know what that is. But at 0, I can, where does it start?
Zero.
And at pi, I don't know where it is.
I swear, minus 5. It's like 9 minus 5.
Do like the same, do like the same before, yeah.
Probably 5.
Five-ish. Five-ish. So I know it starts at -50, but this is a calculator question.
Oh.
Because Chris, I don't know what, like, as Owen was saying, I don't know what numbers to pick. I can either do the trick of 0 pi over 2 pi, or I can do the numbers with t squared minus 5, but both of them kind of wacky. But hopefully, like by brute force, or that you do know how to use parametric mode, you'll get a picture like that. And if nothing else, you should be able to do these two numbers and know that it started here and it ends this direction. Then the next thing says, what is the highest point on the curve? And do not, right there. No, it's not.
Why are they making it so hard?
Because they hate you. We've already discussed this.
Why would it be? Why would it be?
Okay, how do we tell what height is? I mean, highest point
That's what
is
Y is right
first derivative of y of x of dt. Y dx, like what, which one? If I want the highest point, what is the equation that gives me height? Y, so I just want dy dx or dy dt?
DX.
I think it's
Okay, how many say dy dt?
Turn the
How many say
board.
dy dx? Dy dy dt people.
You don't get it.
I got 11, relate, I got 11.69.
Yeah. Okay, so, good point. Austin is saying, does it even matter though, because
Does anything matter?
yes, it does, but dy dt, when is that zero, is also when dy dx is zero. So it will be the same answer. You're doing extra work if you did the whole dy dx. But as Sienna said, to find the maximum y, we need to do dy dt. And where is that zero or undefined? It's never undefined. Where is it zero? Pi over 2. And that's time equals pi over 2. Because if you look on the graph, where we normally would be like, okay, pi over 2 is right there, it's time. We're plugging that into the x and the y coordinates, and it didn't happen to hit on a polar coordinate. You guys okay with that? There's something to that. Time is pi over 2. Plug in time to the x and the y. And then we get the wrinkle of it asks for the highest point. To me, highest point, even though they're saying point, to me it means what's the altitude? What's the height of the mountain? To me it means just height. But I don't know what they're asking for, so I'm gonna be like, well, at time pi over 2, the maximum occurs at pi squared over 4 minus 5, and the maximum actually is 2. So I'm answering everything they wanted. I don't know which thing they want, but they're all there. Chomps, take that.
That's how boss do it.
I think what they're asking for is, what's the maximum height? 2. But first period argued, they said point, Miss Pascal. Like, well, I said when it happened to.
So snap.
So there. All right, but the point of the question and this unit is the double derivative, this for inflection points, these. So there's your double derivative. I just and then divide by dx dt.
Side square. Is it 2 sides? Is it 2 sides? The equation is 2 sines e, 2 sines e. It's 2 sides. I understand, bro. It's 2 sides. I got it.
So where are inflection points? When the second derivative is 0 or undefined and changes sign. That this is a calculator question. You could type that whole equation in, graph it, and find where it changes from positive to negative. But the inflection point, the one and only inflection point in the domain given is 2.798. And t is 2.798. Yep,
And the domain is from 0 to pi.
I believe so. Yes. So there's probably some after that too. In the calculator questions, I really recommend when you're looking at them and typing them in, understand how to use the window, hit mode or window, and set it to 0 to pi so you see the only answers that are available. Let's go back. Yeah. Yeah.
Yes. Yes.
There's another question, so. I know you do. There it is. Find out.
Love the back of the neck like that. Put the next one seriously. Back of the book. Cursing's unnecessary, bro. Yeah, is that what it is? D1 squared over DD squared.
So for potentially, it's because you don't have information.
Oh, wait,
Why is
so is it?
why is it? Nick, how do I do the problem?
You start off by finding dx over dy over dx.
Okay, what is dy over dx?
Well, you do.
I got that.
You got B? D1. Okay, 2.
Please don't leave it like that, reduce. For the love of God, if you don't reduce, this is a horrible, horrible problem.
Where's? I didn't prepare my notebook for this.
All right. So dy dt, 4t cubed. Dx dt, 2t. The one over the other. Not any which way, but the y over the x. Did I reduce it right? Yeah. Okay. Then, Lexi, what is the derivative of this stuff with respect to time?
Would that be 2t squared?
Multiply by the power, lower the power.
No.
And then we need to divide by dx dt again, which dx dt is 2t. So the answer is just 2.
I got that too. You got B.
I'm looking a lot better than whatever
It's close. All right, and then do the homework. And we'll check it tomorrow.
this makes me big chapter 8.